The first several problems in Chapter 14 calculating the concentration of solute in a solution. And what concentration is it's basically a quantitative way for us to express how much of a given solute is dissolved in either solvent, a given quantity of solvent, or a given quantity of solution. So this first problem, number 67, involves us determining percent by mass. Now percent by mass is something we've run into before, and we've usually calculated it by saying, okay, it's the mass of the part divided by the mass of the whole divided times 100%. In the case of a solution, our part is our solute, and our whole is our solution. So percent by mass of a solution is calculated by using something like mass of solute divided by mass of solution times 100%. In this case, our solute is magnesium chloride, and we're told in this problem that we've got 550 milliliters of water. We want to know what our percent by mass is. So in this case, water is our solvent, and it's important to remember that the solution is equal to the solute plus the solvent. So in calculating the mass of our solution, we're going to need to figure out what the mass of our solute is and what the mass of our solvent is. We're given the mass of our solute. We have 25 grams of magnesium chloride, and we're told that there are 550 milliliters of water. So we need to convert these milliliters of water to grams. We do this using density. Density is mass per volume, and we can use it as a conversion factor when we're going back and forth between mass and volume. The density of water at room temperature is 1 gram per milliliter. So we can use this to convert between 550 milliliters of water and to 550 grams of water. Once we've got our mass of water, we can add it to our mass of magnesium chloride to get the total mass of the solution, which is 575 grams. If we divide our mass of magnesium chloride by this 575 grams and multiply it by 100%, we find out that this solution is magnesium chloride by mass. All right, number 71, we're dealing with a different concentration unit. In this case, it's molarity. What molarity is it's moles of solute divided by liters of solution. In this case, we're told that we have 15.7 grams of calcium carbonate, and we're dissolving it in enough water to make 275 total milliliters of solution. So what we need to do is, first thing we need to do is figure out what our moles of our solute are. And our solute, again, is calcium carbonate. So we start off with 15.7 grams. If we want to go from grams to moles, we use the molar mass. Molar mass of calcium carbonate is 100.088 grams. If we make sure we divide by that molar mass, our grams will cancel out, and you'll end up with 0.157 moles of solute of calcium carbonate. We want to divide this by liters of solution. We're told that we have 275 milliliters. There are 1,000 milliliters in a liter. So 275 milliliters is the exact same thing as 0.275 liters. Now we've got our moles of solute, we've got our liters of solution. It's just a matter of dividing one by the other. If you do that, you'll end up with a concentration of 0.571 moles per liter, or 0.571 molarity. Number 76 is a dilution problem. And in dilution problems, you're starting with some sort of substance with known concentration, and you're adding water to dilute it down to a lower concentration. So you'll have a higher volume, but a lower concentration. The whole principle behind dilution problems is that the total number of moles is conserved, or the total number of moles of solute is conserved. So the number of moles of solute you start out with is going to be the same as the number you end with. Even though you're adding water, you're not changing the number of moles of solute. So the dilution equation is expressed here. It's M1V1 equals M2V2. The M's represent molarity, the V's represent volume, 1's are your initial conditions, and 2's are your final conditions. So in this question, you're told you want to make 225 milliliters of 1 mole per liter nitric acid. And you're starting with a 5 mole per liter stock solution. You want to know how many milliliters of that you'll need to use. From here, it's just a matter of plugging things in. You know your initial molarity is going to be 5.0 moles per liter, 5.0 molar. Okay, we don't know what volume of that we need to use yet. That's what we're solving for. Our final conditions are that we have 1.0 molar solution, and we've got 225 milliliters of it. Plug things into our equation, we can then solve for V1. Again, it doesn't matter what units we use for volume. as long as we are consistent and have the same units on the left and right side of the equation. So if we have milliliters over here on the right side, we've got 225 milliliters. Our volume on the left side that we're going to solve for is also going to be in milliliters. So if we solve for that, you end up with a volume of 45 milliliters, which means we would need 45 milliliters of 5 molar nitric acid to produce what we want. Question 80 involves calculating molality. Molality is different than molarity. What molality is equal to, use a little italic m to abbreviate molality, is its moles of solute per kilograms of just solvent. In this question, we're told that we have 75.3 grams of potassium chloride dissolved in 95.0 grams of water. Potassium chloride is our solute here, and water is our solvent. So what we need to do is we need to go from our starting mass of potassium chloride to some moles of potassium chloride, because we need that in the numerator of our molality equation, molar mass. The molar mass of potassium chloride is 74.551 grams per mole. If we divide by it, we ensure that we cancel out our grams, and you end up with 1.01 moles of KCl. So we have 1.01 moles of our solute. Here we need to figure out what we're putting in the denominator. We're told that we have 95 grams of water. There are 1,000 grams in a kilogram, so we have 0.095 kilograms of water. You just divide the top by the bottom then, and you end up with a concentration of 10.6 moles per kilogram, or 10.6 molality. The final textbook problem that just involves calculating concentration is number 83, and number 83 is kind of tricky. You're told that you have a 35% by mass solution of formic acid, and that's all the information you're given, and you're then asked to calculate both the molality of the solution and the mole fraction of the solution. In the last problem, we went over how to calculate molality. Mole fraction is equal to moles of substance A, so whatever substance you're concerned with, could be the solute, could be the solvent, divided by the total moles. So that's your moles of your solvent plus your moles of your solute. And that is it. You don't need to multiply it by 100%. You don't need to do anything else with it. That's how you calculate your mole fraction. Okay, so one of the hard parts about this problem is figuring out where to start. Right? You're just given a percent by mass. You're not given like a volume of your solution or a total mass of your solution. So what you need to do here is you need to assume a total mass to start out with, because we're going to need a total mass to get our total moles and to get our moles of whatever substance we care about, and so on and so forth. So let's start out by assuming that we have a total mass of 100 grams here. If we have 100 grams in total, because we have 35.5% by mass formic acid, we must have 35.5 grams of formic acid. All of our leftover mass is in the form of water. Because we have 100 grams total, we can figure out our mass of water by subtracting our mass of formic acid from our total mass, which gives us 64.5 grams of water. Now that we have masses of water and of formic acid, we can convert those numbers to moles, because we need to use moles in our mole ratio, and we also need to use moles, at least of our solute, in calculating molality. You go from grams to moles using molar mass. The molar mass of formic acid is 46.025 grams. If we divide by our molar mass, we'll cancel out grams, and you'll end up with 0.771 moles of formic acid. Okay, we can do the same thing with water and just use the mass of water in a different molar mass. The molar mass of water is 18.015 grams. If we divide by that molar mass, our grams cancel out, and we end up with 3.58 moles of water. So let's look at this mole fraction first. It's written down at the bottom here. Mole fraction, we want moles of our, whatever we're concerned with, in this case formic acid on the top. So we got 0.771 moles. And on the bottom, we want our total moles, 0.771 moles, which is our moles of formic acid, plus our moles of water. Doing this yields a mole fraction of 0.177. There are no units for this because our moles and our numerator and our denominator cancel out. We don't multiply it by 100%, so there's no percent or anything like that. For calculating molality, we have the same thing in the numerator, our moles of formic acid. And in our denominator, we want kilograms of our solvent, our H2O. Because back in the beginning of the problem, when we assumed we had 100 grams total, this lends us to having 64.5 grams of water. There are 1,000 grams in a kilogram, so that's the same thing as saying we have 0.0645 kilograms of water. If you divide our moles of formic acid by our kilograms of water, that yields a molality of 12.0 moles per kilogram.